Hello good people, this video will discuss question about the calculus rate of change. So the movement of a mosquito which is tied on a plastic spring is modeled by x, or the distance equals with 0.5 e to the power of negative 0.3 t sin 2.5 t, where t is second, and then x is the displacement from the initial position. Find the number of time the particles will be 0.5 centimeter from the starting point. So it means we have to draw it using the graph. Let's just input this into calculator and let's see what's the graph look like. Okay, so y equals with, let's erase our previous graph. Y equals with, 0.5 e to the power of negative 0.3, 0.5 e second e to the power of negative 0.3 t, 0.3 x, because our calculator doesn't recognize the 2 times sin 2.5 t, 2.5 x sec alpha x, like that, and then the particles will be 0.25 from the starting point, so it means y2 is positive 0. It can be positive 0.25, it can be negative 0.25. So 2.5, 0.25, sorry, 0.25, or it can be negative 0.25. Okay, enter, and then let's graph this. See, we got the movement of the spring. Okay, wait, this is still thinking. Okay, we got the one, the line. As you can see, our graph is too big. Let's change the window. In this case, let's x max, let's change to 1, y max, x min negative 1, and then y max, so let's say 0. Y min negative 0.3, because we only look for until 0.25, and then y max 0.3. It's like that. Let's graph it again. Okay, we cannot see that clearly. Okay, this is too big. Let's change that again. Okay, let's change this x max, let's say 3, y max, x min negative 3, and then y max 0.9. So basically the idea of this is to make us see the graph clearly. Now we can see the graph clearly. Sorry, we have some students pop in, so that's why. Okay, let's continue. As you can see, the graph here is not really clear. We have to change the window again. I want the x max to be more than 3. Let's say it's 6. Let's draw it again. Please note down that the time is start from this 0, so we will not consider the intersection less than this. So it should be on the right path over here. Okay, the positive sides, because the time cannot be negative. This is the intersection, as you can see. This one. So from this one, from the graph, we have 4 intersection. This one, this two, this little one, and then this little one. So we have 4 intersections. So to answer this, you can just draw it. Let's say A. You can draw it. Oh my god, my drawing is very bad. You can draw it like this. Where's the reference? Like that, yeah. Okay. Ooh. At least you inform where is that value from. Okay, so we got here 0.25, and then we got here negative 0.25. Okay, so we have 4 times. So 1, 2, 3, 4. So the particle 0.25 centimeter 4 times. So that's it. That's for the part A, how to do it. So B. For B, find the expression for the range for the rate of change of displacement of the time t. For this, we have to do the rate of change means the first derivative. Yeah, let's change this into y equals with something. Y equals with something. Sorry, because we not start with y. X equals with something. Yeah, so x equals with 0.5 e to the power of negative 0.3 t times sin 2.5 t. For this one, we want to use the product rule. Our u will be 0.5 e to the power of negative 0.3 t, and then u accent will be our u accent will be 0.5 times negative 0.3 will be negative 0.15 e to the power of the same one, negative 0.3 t. Okay, let's calculate the v. Then the v will be sin 2.5 t, and then v accent equals with 2.5 cos, the sin become cos, same in the bracket 2.5 t. Okay, so this 2.5 is coming from the derivative of the bracket. Okay, so with that we can just calculate x accent or dx over dt. The rate of change of that will be equals with u times v accent plus u accent times v, or u accent v plus u. Yeah, same thing. Yeah, is equals with, you can basically just input all of the things over here. So the u is 0.5 e to the power of negative 0.3 t times v accent 2.5 cos 2.5 t plus u accent is negative 0.15 e to the power of negative 0.3 t times v is sin 2.5 t, and then we can just multiply that. What do we have? Equals with 0.5 times 2.5. We will have 1.25 e to the power of negative 0.3 t cos 2.5 t. Okay, minus this one 0.15 e to the power of negative 0.3 t sin 2.5 t. Okay, so that's it for the part B. So the rate of change, or dx over dt. Let's mark this final answer. So that's it. So if you have any question or I make mistake, please let me know in the comment, everyone. Thank you and have a good day.